with coordinate geometry, and indeed we are ready for coordinate geometry. So today we are introducing coordinate geometry like I promised, and we can have our heading coordinate geometry. Here I expect people to be in position to remember some things we did discover or discuss in O-level and primary. For example, you should be able to remember how to find the gradient, how to find the perpendicular, how to find the distances between 2 points, and some other definitions which are key in this area. So, first and foremost, one should know that in this coordinate geometry, we mainly talk about the XY plane. We call it the Cartesian plane. XY Cartesian plane. And this XY Cartesian plane has the following characteristics. Characteristics of the XY plane or Cartesian plane. One, has the x-axis, which is always what? Always horizontal. Two, it has the y-axis, which is always what? Vertical. Three, the axes intersect at 90 degrees. That means they are perpendicular to each other. Another characteristic of this Cartesian plane is the axes meet at the origin. Meet at the origin. So those are the characteristics of the XY plane. And if you are to look at an illustration describing the same, can have such a sketch whereby if I can have this as my y-axis, then this as my x-axis, then this is what we label as the y-axis. This is what we label as the x-axis. Whereby if you have a point y, small y here, and a point small x here, these 2 points can define a point P. So if you have a point P defined by those 2 ordinates, then that point P is written as small x, small y, meaning it's a point with reference from the origin, which origin is O here, and O has coordinates 0, 0 as the point of reference. So P becomes a point which is in the XY plane defined by X ordinates, that is, you move X units in the horizontal, and then you move Y units in the vertical. Then from there, we can also go back to what we call lines. A line is a locus of points. A line is a locus of points that are collected together in a given direction. In a given direction. We shall discuss what locus is in future, but if you have points or dots or points that are maybe moving in a given direction like that one, then they will form what we call a what? A line. So lines have important features. Lines have features which include the following. One, A line has what we call the gradient. And the gradient of the line is what we call its slope. Then 2, a line has what we call the Y-intercept. And the Y-intercept is the point which is on the Y-axis, the line point on the Y-axis, where the line cuts the Y-axis, and at this point, X is 0. Then we also have what we call the X-intercept. And for this one, it's a point on the X-axis, where the line cuts the X-axis and Y. And at that point, Y is equal to 0. That is what we call the X-intercept. Okay? So you can consider the diagram below to illustrate that. Consider the diagram below. Consider the diagram below. Whereby if you have this as your Y-axis, let me draw it here. Then this as your X-axis. Then you have a line. This line, let me define it by another color. That is our line. Then, remember you have to label this as the Y-axis and this as the X-axis. This has the coordinate 0, 0. And this becomes what we call the Y-intercept. Then this one is what we shall call the X-intercept. And if the angle it makes with the horizontal is theta, then if you consider a point at P and you consider a point at Q, then at P the point can have maybe ordinates x1, y1. At Q it can have ordinates x2, y2. So that correspondingly you can identify those ordinates on their different axes. Whereby here I will identify this as y2, I will identify this one as y1. Then horizontally, I can identify this one as x1, then I can identify this one as x2. Okay, so still, if one is to identify this line here, you would still see that if this is 90, because of right angle triangle, this angle still will also be theta. Okay, so if that angle is theta, then when you look at PQ, when you look at PQ, for example, line PQ is equal to change in Y, which is the change in Y. Then line, let me call this one point R. Line PR is the change in X. Change in X. Okay, so this one I call it the X-intercept. Then this CY I call it the Y-intercept. Now, from the diagram above, the gradient M of the line, so normally the gradient of the line, we call it M of the line, can be got from M is equal to the change in Y, P2, out of the change in X, which is PR. Therefore, gradient becomes change in Y over change in X. It is from here that gradient becomes Y2 minus Y1 divided by X2 minus X1. The reason why it is Y2 minus Y1 is because Y2 is greater than Y1, and likewise X2 is greater than X1. But you can also use the reverse. One can say X1 minus X2, then Y1 minus Y2, as long as there is consistency. That if you've considered P first, then you're subtracting coordinates of P, take off those of Q. Then if you're using Q first, then use the coordinates of Q, take off those of P. Consistency is required. That is why I'm saying one can also say this is the same as Y1 minus Y2 divided by X1 minus X2. You still get the same answer. Though this one may be a negative, but it will be a negative in the numerator and a negative in the denominator, which still would give us a positivity. So this is equation 1, can derive here, which is reminding us of how to find the gradient of a line. Okay. Now also, if P2 makes an angle, theta with the horizontal axis, P2 makes an angle, theta with the x-axis, then the tangent of theta can be got from, this wasn't P2, this was 2R, sorry, the change in Y. The change in Y was supposed to be 2R. Even here, it's supposed to be 2R, not P2. So this is 2R. Now I can still get the tangent from 2R divided by PR, because one is vertical, one is horizontal. So the change in Y over the change in X. With this, I can confirm that the tangent of the angle of the inclination of the line to the x-axis is always equal to the gradient of the line, which is change in X or change in Y over change in X. So with that, you discover that you can as well get the tangent of the angle. So the gradient M is always equal to tan of the angle theta, which angle theta is the inclination of the line to the x-axis. Theta is the angle of inclination of the line to the x what? Axis. Okay, so in that case, remember also this is equal to the slope. So it means angle theta is equal to the angle of the slope. Also that you can take it as a keynote to identify. Okay. So in case you're to look at various angles and you're to look at a graph like this one, you have maybe here the y-axis, you have here the x-axis, you have different lines like this one, you have another line like that one, yeah, you have another line maybe here which is perpendicular.
Take back a little bit.
Yeah, okay.
Yes, thank you, sir.
You're welcome. Okay, so more definitions can come in if you have this as your y-axis. Then you have this as your x-axis. Then you have this as theta 2. You have this one as 90, but this 90 is theta 1. You have this one having an angle of theta 4. You can even have another line, which is in this case, which is horizontal, whereby this one can have an angle theta 5. So from such a graph of those different lines, it is worth noting the following. So you have to note the following. 1, theta 1 is equal to 90 degrees. That is the case, then the gradient of the line, this is line 1, line 2, line, okay, let's have line 3. This is theta 3, then line 4. So the gradient of the line 1 is undefined, because the tan of 90 is infinity. It is undefined. You are trig machines now. Then 2, theta 2 is less than 90 degrees, as you can see it. Yeah, it means the angle is acute. The angle is acute. And in this case, tan theta is positive. And also, the gradient of line 2, or slope of line 2, is also what? Positive. That is why we end up saying that whenever angle lines are facing in that direction, we say they have a positive gradient. It is because the ratio of their angle, they subtend to the x-axis, identified by tan of the angle, is a positive. Or that angle lies in the first quadrant. So it comes from trigonometry. Remember, if you have all students take cocaine, you remember all students take cocaine? If you recall all students take cocaine, you discover that when you are in the first quadrant, here, all students take cocaine. The angle here for all ratios is positive. So that is why whenever the line is facing that direction, it has a positive gradient. Whereas if it is for tangent and is facing this way, it will have a negative because only sign here is positive. Was it Lutula either having a hand up?
Yes, teacher.
Yes, please go ahead.
So I was requesting for you to repeat that my network was unstable.
I was saying, if the line 1 is at 90 degrees to the x-axis, the angle there is 90. So therefore, tan of 90 is infinity. So it means if a line is perpendicular to the x-axis, then its gradient is undefined, because the ratio of the angle tan of 90 is infinity. Then if the angle for line 2, for example, theta 2 is less than 90, as you can see, it is an acute angle, then it has a positive gradient due to the ratio of tan theta. And I've explained that using the concept of the circle of all students take coffee, whereby in the first quadrant, that line will be directing to the first quadrant. And in the first quadrant, lines or angles there all predict ratios which are positive. So the tan there is positive, and if the tan there is positive, remember tan is defining the gradient of the line or the slope of the line, hence it becomes a positive gradient or a positive slope. Then thirdly, for the lines L3, okay, if you come to line 3, theta 3 is 0 degrees. And in this case, and tan of theta is 0. Therefore, the gradient of line 3 is 0. So whenever you have a horizontal line parallel to the x-axis, Lines which are part of the x-axis have a 0 gradient because they have no change in y. All right. Whereas the ones which are perpendicular to the x-axis, they have a change in y, but they have no change in x. So if they have no change in x, then their gradient is undefined. We saw the reasons earlier. So the last one is, for example, if theta 4 is greater than 90, yeah, that is an obtuse angle. Okay, then theta 4, tan of theta 4 is a negative. Hence, the gradient of line 4 will also be negative. So that is why we have lines running from left to right. From right to left have negative gradients. Okay. So having seen the gradient, I can also get another definition here very fast, which we can talk about. We shall talk about equations of a line, but before that, let's have some few examples to remind ourselves about the gradients of a line. Find the gradient of the line joining points below. 1, 1, -2, and 3, -3. The second one, -2, -1, and 3, 4. Then the third one, -2, -1, and 2, -5. And the fourth one, 1, 0, and 2, 5. So I'm going to work out on the 2. You also try out 1, and the rest you try them later. So solution 1. We are being asked to find the gradient m, which is change in y over change in x. So m, the change in y, remember, is y1 minus y2 over x1 minus x2. So according to the first number, it is 1, -2, and 3, -3. Maybe this one has x1, y1. Maybe this one has x2, y2. But with time, you don't even need to identify. You just substitute because you don't need to formula in pure 1 and get the answers. So y1 is -2 minus 3 divided by 1 minus 3. This will give me 1 over -2. So the gradient is a -1/2. Or whoever thinks of using the reverse, one can say m is equal to -3 minus -2 divided by 3 minus 1. You realize that you get -1 over 2. So they are the same answers. Whatever point you start with, the answer is the same. So before I go to question 2, Swale has a hand. Swale?
So you answered.
Okay. Let me do one more. -2, -1, and 2, -5. The gradient here, m, will be change in y over change in what? Which will be -5 minus -1 divided by 2 minus -2. This will give me a -4 divided by a positivity of 4. When I lose these two, the answer is negativity of 1. Be very sensitive. If you have decided to start with 0.2, which is -5, it's y. Even the x you start with, it's 2. If you have decided to start with -2, -1, then y start with -1 minus -5, x correspondingly start with -2 minus 2. So that we have consistency. Otherwise, the only challenge here is people lose consistency. One uses y of the second one, then uses x of the first one, which makes everything garbage. So try for me number 4 very fast. You have 1 minute so that we can have those definitions done.
Five.
The answer is 5. It's 5, eh? Correct. Now, sometimes they will ask us to find the angles they subtend. Remember, we said the gradient is equal to tangent of the angle of inclination to the x-axis. So you'll have to be in position to find those ratios. If I may give you some few examples on that which are undefined, for example, like this one. There's an example I want to share with you. What if they give you a point, coordinates of 2, 1 and 3, 1, and they ask you to find the gradient and let's find the angle, or the angle of the slope, or angle of the line to the x-axis. You'll definitely get m from changing y over changing x, which is 1 minus 1 over 3 minus 2, and the answer is 0 over 1. The answer, which is what? 0. But the angle of the slope, or angle of the line, is equal to tan inverse of the gradient you've got. Because we saw earlier that tan theta is equal to m. So if I want theta, it's equal to tan inverse of m. So this would be tan inverse of 0, which tan inverse of 0 is also what? 0. So that angle will be 0 degrees. So it means the line is parallel to the x-axis. Whereas if they give you this other one, for example, 1, 2, and 1, 3, then you definitely get the gradient, this one, as changing y over changing x is equal to 3 minus 2 over 1 minus 1. And then you'll get an answer of 1 out of 0. And 1 out of 0 is undefined, or it's infinity. So with that, to get the angle of the slope or angle of the line is going to be tan inverse of 1 over 0. Tan inverse of 1 over 0 is 90 degrees. So it means that line is perpendicular to the x-axis. So that is about getting gradients and how to find the angles of inclination of the lines to the x what? The x-axis. So we have to introduce now and advance to what we call the equations of a line. Now, according to this, any point you have, any point P with coordinates P of x, y satisfies the condition for finding the equation of a line. of the line, bracket straight line. So if you consider an illustration below, you have our axis, then we have our line, we have our y-axis, we have our x-axis. Then we have an intercept here, C. Then we have a point here, P. And our P is X what? XY. So I can have my line represented like this. And then I have a slope defined like that. With those definitions, we can have the following items indicated. For example, this should be that a 90, so that this is change in y, so that you can get to know that this is the y ordinate. You can even identify this as the x ordinate. Then this is 0, 0, the origin. So remember, m is the gradient, which is change in y over change in x. Now, do you realize that the change in y will be y minus c, while the change in x will be x minus 0, because I'm looking at this point at the intercept and the point P as our reference points. So there is this point P and there is this point C. But here at C, we have 0 what? 0 C as the coordinates. That is why I'm saying x minus 0 and y minus c. So after identifying those two changes, when you simplify, you realize m is equal to y minus c out of x. It is from here that we have mx is equal to y minus c, and this is why always the equation of the line is mx plus c, defining y. So this is how the equation of the line comes about. I don't know whether you had derived it in your O level. If you hadn't, there you go. With that note, this is always what we call the gradient of the line. This is what we call the y-intercept. Okay? So this we can call it equation 1 or equation star. So therefore, equation star is the general equation of a line. A straight line. Okay. Note, we can modify this line. Yeah. It can be modified to mx plus a negative y mx plus a negative y plus c is equal to 0, which also takes the form, ax plus by plus c is equal to 0, and in that case, a, b, and c are constants. So we can find the equations of the line or equations of lines using two methods. i.e. 1 by completing squares. I mean by comparing with, so 1 is comparing, by comparing with the equation y is equal to mx plus c. Then the other one is by equating gradients. Second method is equating gradients. So we can now be in position to identify and see how we can derive those equations. So people can take a screenshot, then we can look at examples. Unless if someone has a question before I go for examples. Okay, so examples. They can ask you to find the equation of the line. Find the equation of the line passing through the points A, 1, 4, and B, 2, 5. So there are two methods, like we have said. The first one, we have the equation. That is, you compare the equations. The other one, you equate the coefficients. But the most important thing, both methods need the gradient. So method 1, get m from change in y over change in x, which is going to be 5 minus 4 out of 2 minus 1. And this will give me 1 out of 1, and the answer is 1. Now, from there, method 1 we have said is got from y is equal to mx plus c. So you need to find the intercept by saying y is equal to 1 times x plus c. Find the intercept by choosing any point. So if I use a point 1, 4, I'll substitute 4 for y is equal to 1 times 1 for x plus c, and therefore c becomes 3. When I have identified 3, I substitute and leave y and x as unknowns, plus 3 as the intercept. With this, y is equal to x plus 3 is our equation, using the method of equating or comparing with the equation y is equal to mx plus c. Now, the second method I've said is we equate gradients. So method 2. Method 2, you realize that gradient is change in y over change in x. But for gradient, we use any point. Now, in this case, let me also have this line illustrated. This is our line. And this line of ours has a point 1, 4. And a point 2, 5, point B, and this is point A. It has an arbitrary point anywhere, P, which is XY. So the gradient of AB is the same as gradient of PB is the same as gradient of AP. Those gradients are the same. Okay. Now, because you have already got gradient of AB, which is M, which was got from 5 minus 4 out of 2 minus 1, which is 1, then this is gradient of AB. Then get the gradient of any, either PB or PA. Use any of the two. So for example, if I use PA, I'll get change in y, which is y minus 4 out of x minus 1. This one now is not equal to anything because you can't simplify it. But because of this condition that those gradients are the same, since we are on the same straight line, So the gradient of the straight line is always a constant. Then y minus 4 out of x minus 1 is going to be equated to this other gradient we had before. With that, y minus 4 is equal to x minus 1. Y minus x is equal to 3. If you make it the subject, y is equal to x plus 3. Hashtag same answer. Let me also investigate what if I had used the PB rather than PA. So if one had used the gradient of PB, which is going to be equal to y minus 5 out of x minus 2 is also equal to 1, the gradient of the entire line, using those 2 points which are known. Then y minus 5 is going to be equal to x minus 2. So y will be equal to x minus 2 plus 5. Definitely y is x plus 3. Hashtag is also a solution. So you just pick any of the points, then choose an arbitrary point which has unknown values of x and y, then get the gradient of the unknown point and any point. Then equate it to the gradient of any known 2 points that lie on the same straight line. With that, we would have got the equation of the line. Okay. So that is why we sometimes also we say, sometimes they can ask you to find the intercept. When you have used this second method, then you compare. You say y is equal to mx plus c. Definitely m is equal to 1, c is equal to 3. So you can always be in position to compare and see what you have attained. There is an exercise I'm going to share with you for you to try out, which will be 1, finding equations of a line, 2, identifying gradients, 3, rearranging the equation also to get the gradients and the intercepts. Yeah, so those will be not very challenging questions, a little bit easy. Let me send them even right now so that you can have them there and then. And so that you don't have an excuse of saying that, hey, you forgot, teacher. So these are quite some simple things we've heard of from O level. And I trust most of us can be positioned to handle most of these numbers, unless if you don't want to do the numbers. But if you're serious candidates, I trust you'll solve all these numbers and pass them. Unless if you get a challenge along the way. But Backhouse 1, these are one of the first topics you should go and check on them and see those numbers and see how best you can take them on. We have some 12 minutes left. In these 12 minutes, let's have a look at what we call double intercept equation of a line. And we shall stop at that. Let me use a new page. The double intercept equation of a line. Now, in this case, when the general equation of a line, is defined by the following. Is ax plus by plus c is equal to 0, is written in the form a, not a. It can be x out of capital A plus y out of capital B, maybe is equal to 1. Yeah. Then this resulting equation, is called the double intercept equation of a line, whereby A is the intercept, is the X-intercept. Then B is the Y-intercept. Okay. Rule 2, is this pure math? Please, Rule 2, this is pure mathematics. Later, why are you thinking it's not pure math? This is coordinate geometry. It's pure 1. Tuesday is always for pure 1. Remember, you have back house 1 and back house 2. So we are just still in the beginning, introductory parts. We have never gone any further. So in case you're given such an equation, just know that it's an equation which has what we call the double intercept. And it's called the double intercept equation. So it means it has an intercept in X and an intercept in Y. So they can give you an example and say, express the following lines in the form of X out of A plus Y out of B is equal to 1, and hence state the X and Y intercept in each case. So they can give you an example like Y is equal to 2x plus 1. So you realize that this is a negative 2x plus Y is equal to 1. Okay, so if you divide by negative 2, you'll get, for example, if I divide, this is the same as what? If I divide by negative 2, this is the same as writing it as X over negative a half plus Y over 1 is equal to 1. So it means the X-intercept.
Pardon, sir.
And you see this negative 2, X. I can rewrite it like this as X over negative 1 over 2. Remember, this 2 went up. So we have brought it from up and brought it back down. So it's the same as writing it as a what? As a fraction. Right? The reason why I could not divide everything by 2, it could create a half this side on the right-hand side. Yet the definition says the right-hand side should be equal to 1. So since the right-hand side is already 1, then express those values in terms of the numerator being X and the denominator being any other value. Likewise, the second term, the numerator being Y, the denominator being any other value. When you succeed, those values in the denominator are the intercepts. So the X-intercept is negative a half, while the Y-intercept is positive 1. So Swale, is that okay? Swale? Swale, are you there?
Yes, it's okay.
Let's check this second one. Now, when you look at this second one, you see it doesn't have a 1 on the right-hand side. So you have to first create a 1 by dividing everything by 3. So divide everything by 3, divide everything by 3. The purpose is to create a 1 on the right-hand side. Even here, okay, by induction, you get a 1. So this is X out of 1 plus Y out of 3 out of 4 is equal to 1. Do you see that the X-intercept is 1 and the Y-intercept is what? Is 3 out of 4. You see that? Mercy. Mercy, are you present?
Bye, teacher. Yes.
Yes, Mercy, give me the intercepts of X and Y on this one.
X
X-intercept is -1.
Correct.
And Y-intercept is -1.
Lovely. Thank you, Mercy. Shakira, can you give me the fourth one? Shakira, are you there? She's still computing. Cynthia. Cynthia, give me number 5. The intercept on the X and the intercept on the Y.
X-intercept is 2.
That is Cynthia.
And Y-intercept is
X-intercept is what? You want this number, not so?
sorry, I was given the answer for.
Okay, you come again. Tasneem, get ready for the sixth one. Tasneem, are you ready? Cynthia, Cynthia, you are done something, right? What did you do? You are giving me something. One of them.
X-intercept.
X-intercept is?
5.
Yeah.
The X-intercept is 3, then the Y-intercept is 2.
Are you sure for the second one? Y-intercept is 2. The definition has a plus. Huh?
Oh,
Yeah. So what will it be?
negative.
-2. Okay. Yes, Tasneem. Number 6. Madina. Madina, Tasneem, are you there? Monica Namagembe, can you take it up? Monica, what is the X-intercept? Monica, are you there? Sware.
Yes, teacher.
Yes, give me the X-intercepts. Number 5, number 6.
5 out of 4.
Thank you. 5 out of 4. Y-intercept?
5.
Thank you. Someone give me the intercepts on number 4.
Y-intercept 8 out of 3.
Y-intercept is equal to
8 out of 3.
8 out of 3, correct? X-intercept
It's 2.
is 2. Thank you. So with that, we have introduced coordinate geometry, guys, unless if someone has a question. Since we are still in the reviews of what we did mostly in O-level, we have advanced a little. Try to go and read about 1, midpoints of a line. 2, read about the distance between 2 lines. Then 3, if possible, also read about the intersection of lines. When we come back next week, God willing, we have to finalize all that. And perhaps next week might be our last lesson. So I don't know. I'll see how best we can have to cover at least something really wide. Before 8, what do you guys have?
Before what?
8, because if our last lesson is next week, now as of the view, we can start at either 8 or 8:30. Then we study up to 10:20. But with that, I trust we shall have done a lot on coordinate geometry. By the time you go to school, you can be in position to handle at least something better. So we need to remind ourselves, we shall remind ourselves on Monday, and we see whether we can have at least that time. Okay, we shall start from Sunday so that even Monday we borrow some time, then even Tuesday we borrow some time. Okay. Of 8, we can either start 8:30 or we can start at 8. We shall agree so that we can have.
But
some
I
more
need
time.
to have a lesson on Sunday.
No, I'm saying we can agree on Sunday from the WhatsApp group. Then on Monday, we meet either at 8 or at 8:30. Even after confirming the one for Monday and we meet on Monday, we confirm also the one for Tuesday. Why are you worried of studying on Sunday? Okay. So with that, we can have a good day, unless if someone has a question. Thank you for being patient. I'm sorry I was late again.